Welcome back to the deep dive. Today we're getting into something that, honestly, most of us probably don't think about enough until it's almost too late. We're talking about pedestrian visibility. You know, that split second where seeing someone or not can change everything. Our sources for this are pretty varied. We've got urban planning reports, safety guides, even deep dives into automotive tech. And our mission today is to give you some really clear, practical steps to deal with these visibility challenges. We're talking everything from your own gear to smart city technology.
And that's the core of it, really. It all comes down to time. When visibility is low, a driver's time to see and then respond just shrinks dramatically. We're going to be looking at this from, both sides of the curb, what pedestrians can do and what our actual infrastructure should be doing to help everyone make smarter choices.
Right. It's about moving beyond just wear bright colors. We want you to really get the why behind it, why one material is better, how our cities are engineering safety, and what our cars are doing to see things the human eye just can't. So let's jump right in.
Okay, so let's start with the mistakes, the common pitfalls. The sources are pretty clear that the biggest risks are often these simple little habits we all have. And the number one mistake, statistically, it's thinking that a bright color for daytime works the same way at night. It's this confusion between fluorescence and, well, what you actually need, which is retroreflection.
Okay, that is such a key point because everyone has that neon running jacket.
Right.
And you feel so visible during the day, but you're saying at night that's a failure of physics.
It is, precisely.
Right.
That neon yellow or bright orange, that's fluorescence. It needs sunlight, UV light to pop. At night, without a light source, it's just a dark piece of fabric. What you need is retroreflection. That's the tech in those silvery strips. It's made of millions of tiny glass beads that bounce light directly back to its source.
Back to the car's headlights.
Exactly. One study we looked at said good retroreflective material makes you visible up to 500 feet away. Compare that to maybe, 100 feet in dark clothing?
Wow. That's the difference between seconds of reaction time versus milliseconds.
It's a huge difference, which really makes the case for, what you called accessory power. Your personal toolkit has to start with dedicated retroreflective gear.
So we're talking vests, armbands, that kind of thing.
Yes, think strategically. A little reflective tape on a backpack, on your shoes. And another thing, actively use a light source. A flashlight isn't just for you to see the path.
It's for others to see you.
Right. You're signaling your presence. If you're coming up to a crosswalk, sweep it back and forth. You're trying to break through that driver's tunnel vision.
And what about the other don'ts that the sources pointed to? I saw a lot about eye contact and blind spots.
Oh, yeah. Huge ones. Especially with how big trucks and SUVs are getting, we just don't realize how massive those blind spots are.
So making eye contact is that final confirmation. You know they've seen you.
It's an active safety measure. You can't be passive. And with blind spots, you just can't assume a driver sees you when you're popping out from between two parked cars. The whole geometry of the situation is working against you.
And this all just gets amplified when we start talking about more vulnerable groups, like kids. I mean, they're shorter, so they're hidden by more things. And they're just not great at judging speed and distance yet.
Exactly. For kids, the safety measures really go from being suggestions to, well, they should be mandatory. The reflective gear is non-negotiable. But you can also make it fun. Leverage their interest in cool stuff. Light up shoes, backpacks that have little linking LEDs built in. It uses novelty to deliver visibility.
That's smart. And the buddy system isn't just about feeling safer, is it? There's a visibility component.
A huge one. A group of kids is a much bigger, more complex visual target for a driver's brain to pick up on than one small child. It gets spotted sooner.
But the training is still crucial.
It's everything. It's more than just looking both ways. We have to teach them to look through the car window. Is a driver actually in there? Did they see you? Making that eye contact. It's teaching them to be defensive walkers.
So let's shift to a common scenario. What if your route home is just dark? There are no other options. We know that darkness plus bad weather is a terrible combination for visibility.
It is. So if you can't avoid the route, you have to mitigate the risk. Stick to the outer edge of the sidewalk, away from the shadows of buildings. Or if there's no sidewalk, walk facing the traffic.
So you can see the headlights coming.
It gives you the best chance to see them and react, and the source is all stress being predictable. Don't make sudden, erratic moves. A driver's brain is trained to look for patterns, and a person walking in a straight line is a much easier pattern to identify.
And I'm guessing the biggest personal sacrifice you have to make in these situations is putting the phone away.
Oh, completely. It has to go away. Distraction in the dark is so dangerous. I mean, think about it. As your visibility goes down, your need for your other senses goes up. If you're looking at your phone or blasting music, you're cutting off your hearing, you're pulling your focus inward, and you're killing the peripheral vision you need to spot danger.
Okay, so we've established that we have to be diligent, but let's shift the burden, because a lot of this should be on the people who actually design our roads. Infrastructure is the ultimate safety net.
It really is. And we need to get past just using basic paint. Let's talk about crosswalks first. Instead of just standard zebra stripes, a lot of places are now using this high durability thermoplastic material.
I think I've seen that. It looks thicker than paint.
It is. And it has retroreflective glass beads embedded right in it. So it stays visible for years, not months. And it works even when the road is wet.
And then there are the physical changes, the things that actually calm traffic down.
Right. Curb extensions, some people call them bulb outs. They're brilliant. Yes, they make the street shorter to cross, which is an obvious win.
Yeah.
But the really clever part is how they change the sight lines. They force the driver to make a slower, sharper turn, and they push the pedestrian further out into that line of sight, so the driver has to see them before they even start the turn.
That makes so much sense. And refuge islands, those little safe spots in the middle of a wide road, they seem to change the whole crossing experience.
They do. They break one really complex, stressful crossing into two much simpler ones. And they also have the subtle effect of physically narrowing the lanes, which psychologically tells drivers to slow down.
Okay, let's get to the big one. Lighting. Street lights. We know they're essential, but what's new here? I hear a lot about the switch to LED.
Yeah, the transition to LEDs is huge. We're moving away from those old orangey sodium lamps to brighter, whiter light. And LEDs give you much better color rendering. That just means colors look more like they do in daylight, so it's easier for a driver to distinguish a person's blue jacket from a gray wall behind them. The contrast is much better.
But these upgrades aren't cheap. Are there any trade-offs? I'm thinking about those smart lighting systems that dim down when no one's around to save energy. Does that create a new problem?
That is a fantastic question. And yes, it's a real debate. Those systems are incredibly energy efficient. But the critics argue that, maybe the light doesn't brighten up fast enough when you walk into the sensor zone.
Or that the general dimness just makes the whole area feel less safe, even if it's technically lit when you're there.
Exactly. Perceived safety is a big factor in whether people choose to walk at all. So it's a cost-benefit analysis. The best compromise seems to be using that adaptive lighting in quiet residential areas, but keeping constant high-brightness LEDs on at all major intersections and crosswalks.
So even the best infrastructure has limits. Human error is always a factor, which I guess is where technology comes in as the final backup.
A non-negotiable backup, absolutely.
We mentioned ADS, Advanced Driver Assistance Systems, earlier. Let's really get into how pedestrian detection works. It's not just a simple camera, right? It's a whole team of sensors working together.
It's a team. It's called sensor fusion. And you need the team because each individual sensor has a weakness. You start with the camera. It gives you a really clear picture, and it's great for figuring out what an object is, a person, a bike, a sign.
But it's useless in fog or heavy rain or just darkness.
Fails miserably. So to back it up, you have radar. Radar sends out radio waves, and it's fantastic at measuring distance and speed. Plus, it can see right through fog and snow.
Okay, so what's the downside to radar?
It has poor vertical resolution. It can tell something is there, but it struggles to know if it's a low-lying fire hydrant or a person's leg. And that's where the third sensor, if the car has it, comes in, Lidar.
Light detection and ranging. This is the really advanced stuff.
This is the game changer. Lidar uses pulses of laser light to build this incredibly detailed 3D map of everything around the car. It's a point cloud. So even if the camera is blinded by the dark, the Lidar can see the unmistakable geometric shape of a human.
And the radar confirms it's moving.
Exactly. That fusion is what allows systems like automatic emergency braking or AEB to work reliably.
And how fast does that AEB system need to make a decision? I mean, from seeing the person to hitting the brakes.
The time frame is brutal. It has to be faster than a human, which is about 3/4 of a second. The system has to see the object, identify it, calculate the collision path, and slam on the brakes in, a fraction of a second.
What's the biggest challenge for it?
The classic dart-out scenario.
Yeah.
A kid running out from behind a parked van. It just gives the system almost 0 look-ahead time.
So let's flip this to the city side of technology. What kind of smart infrastructure is out there?
Well, you're seeing more smart traffic signals. They use thermal cameras or little radar sensors to see if someone is actually waiting at the corner. They can even hold a green light longer if they detect a group of slow-moving people, like seniors, are still in the crosswalk.
And what about that next step, where the car and the city actually talk to each other? V2I.
Vehicle to infrastructure. That's the holy grail. Imagine a sensor at a crosswalk detects a pedestrian in a driver's blind spot. Instead of just flashing a light, it sends a digital warning directly to the dashboard of the approaching car.
So it completely bypasses the driver's own senses.
It gives you a layer of redundancy that neither the car nor the crosswalk could ever achieve on its own. It's a true safety net.
Okay, we've covered personal gear, infrastructure, and technology. Let's finish with that worst-case scenario. You're walking, and you know a driver hasn't seen you. What do you do in that exact moment?
The protocol is simple. Signal and retreat. First, you have to make yourself as visually disruptive as possible. Wave your arms frantically. Flash your phone screen, a flashlight, anything, right at the driver's window. Your goal is to snap them out of whatever they're focused on.
And if that doesn't work, if the car's still coming?
Immediate retreat. Don't hesitate. Just step back onto the curb or into a safe space. If you have to move quickly, move straight back or sideways, perpendicular to the car. Don't run diagonally into the street. That can just confuse a driver who's finally reacting. And shout, use your voice.
So if we boil this whole deep dive down, what's the one thing you want people to take away from this?
That visibility isn't a given. It's not the default state. It has to be actively engineered and maintained. Real safety happens where all three of these layers overlap. Your reflective vest is great, but it won't help much if a car is going 60 in a residential zone. And that car's amazing AEB system is going to struggle if the road is pitch black with no streetlights. It takes personal action, it takes demanding better infrastructure from our cities, and it takes pressure on car makers to keep improving this technology.
That's a great point. It moves safety from being just reactive, a driver trying to spot someone, to being proactive, where the safety is actually built into the entire environment around us. And that brings us to our final provocative thought for you today. We've talked a lot about how these vehicle ADAS systems and smart crosswalks are collecting huge amounts of data on pedestrian movements, on near misses, on where the riskiest spots in a city are. So if this data is the most powerful tool we've ever had for predicting and preventing these incidents, how can our communities get past all the privacy concerns and red tape to actually use this information to fundamentally redesign our neighborhoods for maximum safety and visibility? That's the question we'll leave you with today.
Please like, subscribe, and get notified.